So today I'm going to cover about wave. First question is, what is wave? Wave is the transfer of energy. In simple words, wave can be described as a transfer of energy. For example, ocean waves, light waves, sound waves, heat waves, etc. In fact, information what we are receiving through mobile or radio, all we receive by waves. Next, we should discuss about type of wave. Type of waves. In broader way, waves can be classified into two categories. One is mechanical wave and second is electromagnetic wave. So in this chapter, we'll only discuss about mechanical waves. So we'll only study about mechanical waves. So in a wave, energy and momentum is transmitted by oscillations of the medium particles. So for the propagation of mechanical waves, we need medium. And for electromagnetic waves, which is also called non-mechanical waves, they do not need any medium. But for mechanical waves, the energy and momentum is transmitted by the oscillation of medium particles. So to understand the waves, we will use the concept of oscillatory motions. Next is characteristics of mechanical wave, or we can say properties of the mechanical waves. So there are three basic properties which decides the characteristics behavior of the wave. So three basic properties. First is amplitude. Normally denoted by capital A. Second is frequency. and third is velocity. Now we'll define one by one all three basic properties. So question is, what is amplitude? So amplitude is defined as the maximum displacement of oscillating medium particle particles from their mean position. From their mean position, and it depends on the source of oscillation, or we can say the wave generator. So amplitude is defined as the maximum displacement of oscillating medium particles from their mean position. Second is frequency. Frequency, as we have studied earlier, it is the number of oscillations made by the medium particles per unit time. It is the number of oscillations made by the medium particles per unit time. It depends on the source of oscillations. Very important points. It depends on the source. It depends on the source of oscillation. One important note: frequency will remain constant wherever the wave goes. Means if medium changes, say from one gas it is going to another, frequency will remain constant. It depends on the source of oscillation. So frequency will remain same throughout the wave propagation. Next is velocity. Velocity of wave. It is the speed with which energy transfers through a medium. So it is the speed with which energy transfers through the medium. So it mainly depends on the physical property of the medium. Important points: depends on the physical properties of the medium. So out of the three basic characteristics of a mechanical wave, amplitude and frequency, we can write here as a note: amplitude and frequency depend on the source of oscillation. Whereas velocity mainly depends on the medium which carries the energy. So amplitude and frequency depends on the source of oscillation, whereas velocity depends mainly on the physical properties of the medium through which wave is propagating. Now the type of mechanical waves. In broader categories, mechanical waves are classified as transverse wave and longitudinal wave. First is transverse wave, and second is longitudinal waves. In transverse waves, as these are mechanical waves, so oscillation of the medium particles is the cause for the propagation of energy or propagation of wave in the medium. In transverse wave, if energy is moving say left to right, if we consider any particle of the medium, when the oscillation of this particle will be perpendicular to the motion of energy. This is the motion of energy or flow of energy. And its oscillation about its mean position is in vertical direction. So all the particles is vibrating or oscillating about their mean position, which will be perpendicular to the motion of the velocity of wave. This is a transverse wave. And in case of longitudinal wave, say if energy is moving same from left to right, then the medium particle, if we say example A is the medium particle, it will oscillate about their mean position along the direction of the propagation of wave. This is the velocity direction. velocity of wave or energy flow direction, but the particles are oscillating about their mean position in the same direction. If you take any other point B, it will oscillate parallel to the velocity of wave. So in case of longitudinal waves, medium particles are oscillating about their mean position in the same direction as the direction of the wave. In transverse wave, medium particles are oscillating about their mean position perpendicular to the motion of the wave. So the simplest wave in this topic, we will only discuss simplest form of the wave, that is a simple harmonic wave. The simple harmonic wave. So in the next video, we'll discuss about simple harmonic waves and how it can be represented by a mathematical equation, and then we will move on to different topics.